So this one's going to be a little bit faster than normal. I want to take the time also to help you with your modeling assignment because that's due next week. So I want to give you the time to, I don't know, either use the end of this class to ask for help or just work on your thing. How many people have finished their mid-poly, like the blockout stage? Okay, the people, you might want to get going on that. How many people finished their low poly and high poly? Okay, like 3. Okay, you have 1 week to finish your low poly, high poly, UV everything, and texture it. So that is quite a bit of work. I would recommend taking a little bit of extra time this week to polish that out. Okay.
Tuesday, right? So the 7th.
7th, yeah, the Tuesday. So after Superior's lab, so they'll have like the final say in your help. Try to have something to actually let him help you with when you come to that. All right, so the first thing I want to talk about is blend modes. So this is pretty familiar to a lot of you, and if you've used Photoshop, you also know what these are already, but I think it would help if we went over what's actually going on in the back end when we're using these blend modes. So we've used them already in Substance Painter, and I'm just going to crack open a demo file I have. That should help. Nope, not you. Nope. Don't know why that's here anyway. Let's use this one. Okay, cool. So I've got a little file here. I'll be using this one to demonstrate some of the topics we're kind of going over here. So the whole thing that we're trying to do in Painter is make masks. And we need to understand how the masks actually come to be and how we can control them to a various amount of levels of detail. In this case, if we look at an object like this, which was just that ripple from a few classes ago, big white shape, lots of little small detailed shapes. We're going to work from big to small building our mask like we're kind of sculpting. What we're actually building in the masks is textures. There are 2D textures made of pixels, as you all more or less know. It should be pretty familiar to you by now that the pixels that we have also are represented in numerical values. So our pixels range from usually values of 0 to 1, depending on your type of texture. In this case, we're working with masks, which are purely grayscale, so they work typically in 0 to 1 since there's no color to multiply together, right? So if I have a value of 0, I'm looking at pure black. If I have a value of 0.5, I'm looking at about half black, gray. 0.7, closer to white, and then 1, fully white. So what our blending modes are doing, it's actually pretty simple. It's just going to look at every single pixel on one of our textures, every single pixel on another one of our textures, and then perform some kind of operation using the number it gets from each pixel. So if you're making a mask, and you have a pixel with a value of 0, and a pixel with the value of 1, okay, and we add those two numbers together, what number do we get? 1. You should all know that. You're older than 3. My kindergartners do that. So here, this equation, right, this plus, we can also refer to that as additive. And when we use our blend modes, that's what we call it, additive. So the ones we're going to be using the most are the ones that are built directly on top of actual math. There are other ones like screen, overlay, dodge. We'll get into those ones a little bit later, but the core ones you're going to be using: adding, subtracting, dividing, right? All built in, all easy to understand because they are quite literally math, right? The multiply layer, it's pretty whimsical. People use it all the time. Great for painting shadows and everything else. What is it actually doing? Multiplying. It's not like a pseudonym. It literally is just multiplying the numbers together, right? So anywhere we have 0, we're going to get 0. Anywhere we have 1 and 1, we'll get 1. Right? This should be pretty easy to understand conceptually. What does this actually look like when we apply it to textures? So what's happening on every pixel in our texture? If we take an example like this, all of the black pixels are going to be zeroed out here because they'll be added to these ones, right? So 0 plus whatever pixel amount is in that black circle is just going to end up being whatever's in here. On the flip side, this white value representing the grout coming out at 1, if we add anything to 1, it's going to cap at 1. We can't have like white 2, it's just white. It doesn't go any higher than that. So over here, our white pixels will overlay, and our black ones will let the other texture show through. Okay, we can flip this as well. All right, so if we subtract, it's going to do the exact opposite, but still super easy to understand. Anywhere we have a white pixel here, we'll subtract whatever value is here, and we end up with this. I've got this a little bit backwards, but I'm actually subtracting the bricks here. I swapped these images. Pretend it's this equation. I swapped them by accident. So we're subtracting the bricks from the cloud. Order does matter, just like if you're subtracting real numbers. When we subtract these white values from this, anything minus 1, because it goes to 1 at a highest, is going to be 0, right? It caps at 0, same way it caps at 1. So we end up with our in-between lines. Right? How is this order determined? Well, not there. Our layer stack determines the order. If I put this underneath and had it set to subtract, it literally wouldn't do anything, and this normal layer would just overwrite everything. So you do have to pay attention to your layer stack, and note everything I'm doing here, it still is just in the mask fill layer. If we leave the mask fill, so if we go over here to the color fill stuff, all of this still applies, but it works differently. Where instead of multiplying just the two values together, for example, we're multiplying the individual color values for every single pixel. So red, green, blue, all getting hit and multiplied. Okay, I won't spend too long on this because you should all mostly understand it. There is a website you can check out as well. I just linked it in the slides that I will make downloadable in a second. But basically, it goes through all the more detailed ones in case you're curious. For example, overlay is one that does a screen on values lighter than 50% and a darken on values lower than 50%, so it kind of works like a contrast. Not all of these are going to be in Painter, and not all of them share the same name, but for the most part, they generally work the same. So, for example, if we go to lighter, well, in our case, it would be called light in. When we go to the Painter blend modes, so something like light in, darken, we'll take the lower of the two values if we have pixels. So if we have a bunch of, here we go, we can just start drawing things. Let's add another fill layer. The majority of this is just applying to fill layers, I should mention, where we use our black masks. So let's paint a little bit of something on here. I'll just add some paint. Go to my mask and just paint. Okay. And then I just want to change this to more of a gray and paint that in. So if we have some values here, in this case just some white, some gray, and some black. If we add a new fill and set it to darken, any of the values in my new fill layer that are lower than my base layer will slowly be faded out as we decrease the value here, right? So the white values are going to be the first to go without the gray values even be affected at all. This is because at this point here, this 0.77, it's still brighter than our gray pixels. So it's not actually affecting them at all. It's just affecting the white, right? Because these values are all going to be lower than 1. Once we cross this value, 0.4 looks like, now we're affecting our gray value too. Okay, this can be really useful when you're doing things like edge damage, because you might procedurally want to cut into the mesh, and you can do it by leaving a base behind it and cutting in. For example, I have another demo here just for anchor points. So this is not a kind of texture you would normally make. We'll learn about these kind of textures in Substance Painter, but this is just what I made for an example. We can use darken on things like edge damage. Turn all this off. I have these bricks and I want to cut away at their edges to make the shapes a little bit less uniform. By default, it's going to blur everything together and I'll get a nice mix of light and dark parts. But what I really want is to use minimum to just cut out at the mesh that I've got. I'm not looking to really blur in between the two values. I just want to cut out where I have. On the flip side, if I wanted to just adjust the part that is lit without affecting the in-betweens, then I can switch it to max, which is going to do the opposite. Max is the same as lighten, where it's going to pick the lighter of the two colors, or values. Okay. A lot of them you'll have to sort of play around with and explore as you go through. Usually when working in Painter, a big part of it is just going to be adding a layer that does something you think you want it to do, clicking into one of the blending options, and then literally just hammering the down and up keys until you end up with an effect that you're looking for. So at least I'm pretty sure that's still how it works. If I hit disable here, I can just hammer through the keys, changing the blend mode every time. So I'll just do this here, right? And they're all gonna look mostly the same because I'm doing it on top of this entire thing. Maybe I'll pick this one. Set it to something, move through. That way, even if you don't understand what the blend modes are doing and don't know what to look for right away, you can get a good idea, right? Maybe you find something interesting too. So dividing is gonna make it opposite and invert it. Light, dodge, etc. So if you're ever stuck, start mashing through. There you go. How these blendware works is they're in order, and you can stack them. So we do have not really a bed mass situation going on because we can fake the order as much as we want, but generally speaking, we're going to be multiplying things in first and then maybe adding things on top after. So it is sort of similar in our structure. We do work bottom to top, and we're trying to work in steps as if we're painting, generally speaking. So we're working from our bigger blocks and shapes down into our smaller finite details. So in the case of these bricks, right, I'm just going through the layers and enabling them as I've turned them on. As you can see, we start with a big blocky shape, which is just the bricks as they are, like this, right? We're adding a little bit of variation using multiplication. That's going to add some texture to our bricks, some darkening to cut out those edges, a levels node, which we'll talk about a bit later, and then multiplying more grunge on top. All right, so we're working from the large shapes down to these small finite details. Okay, so that's blend modes. Pretty intuitive, not too crazy. Make sure you try out a bunch of different ones as you're texturing to get the best result. Some additional tools, if you're familiar with Painter now, and from what I saw for the lab assignment submissions, there was a lot of using like the smart materials and stuff. We're gonna talk about the smart materials and a couple other things that you might wanna use. The first one is anchor points, and this one can be kind of hard to get your head around. If any of you have done programming before, it'll be super easy because these are essentially just reference pointers. What they do is take whatever mask you've built, and at your anchor point, it's going to store a copy of that mask. Okay? So if you're ever working on a structure like this, in this case I'm using the bricks again, for example, I've got my bricks 0, 1, which is that big clean shape, and my blur slope, which is cutting out those edges. On top of that, I've got my anchor point. And I've disabled that top concrete grunge layer, which is just adding more variation. But if we go in here to my mask, the anchor point is something I can use on another part of my material, somewhere totally separate, just uses that information. I don't necessarily want all of this information. In this case, I want an anchor point that just tells me where my bricks are and where my bricks aren't. Right? I can use this to add height variation and color variation specifically to where my bricks are, or specifically to the grout, instead of having a bunch of overlaying things on top of one another. So that grunge concrete dusty I have here, since it's above my anchor doesn't actually contain this information, right? It just contains what's below it. So this is what my anchor is going to look like, and I'm pretty sure I have that in the slides too, right? Only those two are going to show up in my anchor point. Okay. We can then use these anchor points in other places. So in this case, I just used it for color variation, and I've used it in a fill. So normally we go in here and we start with a black mask, just like we do. So I'll go in here, mask. What I can do is add a fill to my mask, and under my grayscale options, I have, alongside resources, anchor points. So I've just named this one bricks anchor, and you see it highlights where it is in my file, and it's just going to tell me, okay, this one is my bricks. And when I click that to fill, my mask is starting out as a copy of what was down here. So why is this good? Why is this important? Why do we need to do this? Well, for one, if I make any changes to my bricks later, let's say I'm not happy anymore with the tiling of my bricks. So let's change that. Let's add some more bricks this way. Now it's not really bricks anymore, but whatever. Because I used an anchor point and not just duplicating these layers into my other mask, if I go to my fill, it's going to replicate what I've done here. So this is incredibly powerful, probably the most useful tool in Substance Painter when we get around to things. It can just be a little bit tricky to understand. Okay, so same thing. I can change it back all I want. Just make sure we're on the mask. And boom, it's still going to apply to all of my other layers. Okay. And so from here, I can start to build on it as if, you know, I have these two layers below it. So let's add grunge, concrete, dusty. I'm adding a little bit of variation, using the levels to balance it out. And then in my fill, that ends up being just a little bit of color variation on my bricks. Okay. The areas where anchor points are going to be the most useful is when we're creating either repeating or individual details in our textures that don't exist on our mesh, right? If these things exist in your mesh, it's a lot easier to just flood fill the mesh with its own mask, right? Just like we were kind of doing last week where I made everything red. But this way you get individual control over specific repeating elements in your textures. Right. Another reason anchor points are great is, let's say we're using height data for things. If I go into my grout, which is my base layer, so if I turn everything off on top, it's just my base layer. You can see it affects everything: color, height, roughness, metal, right? As our base layers should. And building on top of this, we want our bricks to sort of have a little bit of height. That's just going to help them stand out in the normal map and separate them from everything else. The issue is, if I take, where's the mask? Oops. If I take this fully detailed value and throw it into my height map, I might not get the results I'm quite looking for, at least at the start. I might want to go back and add height variation afterwards, but for now, I just want a clean height map, right? And so anchor points are another great way to do that, because I can remove the detail layer I added. And if I go into my height now, screen is small. If I go into my height now, you can see I've actually filled my height, right? So just like normal, I filled my height for my bricks with my anchor point. So now if we look at the height map, you can see it's just the clean details. Very easy for the program to understand this as a height map. It's not noisy, it's not too detailed. And afterwards, I can come back with some kind of normal map detail and overlay that on top of my height, right? Because we don't need every individual pixel to be a different height. We don't have that kind of resolution, technically, on our mesh. And what we end up with is a combination of both, where now I've got the normal map. I haven't done anything to the normal map. It's just doing this with the light because of the height values, right? And they're nice, clean height values, so we're not getting all this noise inside here, where we otherwise would. Okay, so anchor points are going to be incredibly useful. We'll explore them a little bit more with certain materials as we build up. I'm assuming I do have some. Kind of just demonstrate this in the slides, but they're in the slides as well in case you want to learn more. Next is smart materials. So you should all be kind of familiar with this because I think most of you use them, but you probably don't actually understand what's going on with them necessarily. I could be wrong. Do you guys feel like you understand what's actually happening with the smart materials, or is it kind of just like drag them on, boom, it's texture? Okay, so most of you are in the like drag them on, boom, it's texture category. That's okay. last week what we did is, essentially, if you followed along with what I was doing last week, I was building a smart material. You just didn't really realize it. But all the smart materials that you use are built in that exact same manner, where we build up a base layer, we set up our mask, and then we build a bunch of different smaller masks on top of it that add detail, right? So we have an entire library here, which is fantastic. My library is actually pretty small. I don't have all that many, but your library at the moment is probably even smaller, because a lot of these are either ones I've bought over the years or ones that I've made myself. All of the stuff that you've done in your smart materials, or just your materials for texturing, because we're doing it procedurally, that's why I've kind of had you avoiding all the like painting and things like that. We can get into the painting when we have the nitty gritty, but all of this stuff, if you do it procedurally and use the masks, right, can just be turned into a smart material that you can reuse on other projects, on other things, whenever you want. So this is just, I dragged on a steel paint material. So if we just turn this off, look at this one. And that's a bad example, so I'm going to open this. There we go. So down here on the bottom bar, we have base materials, which do not use any mesh maps. So we've been talking about mesh maps and how they're useful. Smart materials will generate on top of your mesh maps. So in this case, if I just pop this open, I probably have different ones on this laptop than I had on my computer at home, to be honest. But we'll find this one steel painted, right? So by default, this steel painted, it's giving us this nice edge where the paint has kind of rubbed off, and we've got this steel underneath. But if we actually open up the layers, we can see it's no different than the stuff that we were doing before. I've got a base layer that we've built up, and I'll just move this over to the side so you guys can actually see it a bit better. There we go, please. That did not work. There we go. Nope, not that. Come on. There we go. So we've got a base layer built up with our default values, just like we have been, and maybe a little bit of color just to add some variation later. We've got metal details working on just our height and roughness with a mask that's filled in with some kind of fill, right? So there's no paint in any of this. It's all procedural. We've got a procedural fill with our dirt. We've got a procedural filter with our blur. Okay, if we look at the mask itself, you can see it's just adding little specks of normal map detail all over our mesh. With paint, it's the same thing. We look at our mask. Okay, we've got a mask editor. So mask editor is a deprecated form of using your mesh maps. Nowadays we have specific generators for each mesh map. In this case, I'm pretty sure it's just using cavity, even though it's actually called, don't stop doing that. So we can go down here and we can scroll and we can take a look and we can see it's using our curvature map, exactly. So it's using our cavity map and it's overlaying a texture on top of it to get those edges. You can see that up here. We have texture 1, texture 2. Our ambient occlusion map is not being used. Our world space, position, thickness, right? All of these are mesh maps that we've talked about in the past. It's just using the curvature. Okay, and that's grabbing those edges and then adding some noise on top to make it look a little bit nicer. Where were these? Okay, and then we're warping it just a little bit just to help clean up the edges. So this is all stuff that you've been doing. This is not necessarily surprising to you. If you followed along with the lecture or tried to do it by bit in the lab, you would have created technically a smart material. Okay. So here's just a GIF showing off how it works the same way. The compression absolutely destroyed the bit rate, but it's fine. Right, but you can see what each layer is doing individually as we turn it off and on. Right. So here is another example of a smart material that's much more complex and honestly not super optimized because I made it like 4 years ago. But the same principle applies. I've got just a ton of different layers building up on top of each other, all with different masks that are just being filled out procedurally based on the mesh maps specifically. And then at the very top, where my folder is is again where we're going to apply that black and white mask for which parts of our mesh we want to apply this to. Everything inside of that is using the mesh maps. Okay, so this is a little bit much. But once you have built this, right, let's say you're building it for your assignment. Maybe you're building a, I don't know, 3DS, like half a V-bar. You can build up a 3DS specific material. It's got that little internal reflection and all of those nice clear coat details on it. Once you've built that up, you can start applying it to anything else you want as long as it has mesh maps. So in this case, this material was built for a table I made like 4 years ago for Ubisoft Next, just in a day. It wasn't super crazy complicated or anything. But now after that day's work, I've got this wood smart material I can apply to anything going forward. So anytime I need extra wood material, I can quickly start with this and make tweaks here and there where I need to, right? It doesn't take too long at all. Okay. So smart materials are incredibly powerful. If you want to actually make a smart material, this one I left out of the slides, but you're here in person. If you want to actually make a smart material, we'll go ahead and we'll actually just build one ourselves right now. If you're curious how I got to this file, or if you want to follow along, you can just go ahead and pop into File at the top left, go to Open Sample, and then this one's called Meet Mat Sample. So this is the default. This is sort of like the Suzanne monkey blender thing, but for Painter. This is like the default. You can check your materials on here, and there's a render view as well for checking out how they look. Okay. So let's get in here and we'll start by making some kind of smart material. I'm not going to make anything too crazy, but I'll just explain the thought process. So I want to get started by adding a fill layer just like anything else. Pop in a fill layer. We'll double check what we're on here. I'm just going to make it bright red just so I know. So we're affecting the entire thing right now. All right, all stuff you've done before. Let's make, I don't know, let's do like a concrete. I don't think there's very many good options for smart materials for concrete, so we can kind of just make our own. So we'll start with the base layer, and I'm going to up the roughness quite a bit since it is going to be concrete, something like 0.7. It's not going to reflect a lot of light. I'm going to go over here to the render settings, which I'm also going to explain a little bit more later. But I just want to scroll down until we find tone mapping. So I kind of briefed through these settings last time I was working on this, but we have different environment maps. The default one on the sample project is Studio Tomoko, and if you're doing any work for game engines, you want to change this to Studio Tomoko from whatever it's at by default. And then just scrolling down here, where the function is set to linear, think about your end result for where you're building these materials. In my case, all the work I do is in Unreal, so there's no point me using linear. I'm not working in Unity, so I'm going to set this to aces, which is the same as what Unreal uses. So right away, you'll see it looks a lot different. The main differences between the two is going to be in the way metals are presented. So if I just drag this metal on top of here, in Unreal, metals tend to be a lot darker. They don't quite absorb as much of the light. They reflect a ton of it. So if we go back to linear, you'll see this will brighten up quite a bit. Okay. So depending on what you're making your stuff for, do keep this in mind. You're going to be using either linear or aces. There's a third weird way to go about this, where if you're using custom color LUTs, you can actually import them here. Right, so let's say my game is being made with a sepia filter on for some reason. I can also enable a sepia filter in here just to make sure that my material matches whatever it's going to look like in the engine later. You'd have to make your own color profile, but that's something you'll learn in CG. So let's put it back to aces and get rid of this metal, and we'll just go back to our fill layer. I want to start with something that is gray. Naturally, we're going to do some kind of concrete, and we're keeping our values pretty much in the middle for now. I'm not going to move too far to one side yet. We'll come back and knock those details out later. Okay, and we'll just call this base. I'm going to make a new group and call this concrete Warren, for example, and just pop our base in there. We will need this group later to actually create a smart material out of this. So if you see, if I right click on a layer, I get a bunch of cool options, but nothing we're really looking for. If I right click on a group with layers inside of it, you'll see there's an option that pops up for create smart material. So the actual creation process, once you have all of your layers built up, is incredibly simple. So let's work on this concrete a little bit more. Right now I've got this base, it's great, it's affecting all of our channels, so we have a nice 0 point to work from. 0 metallic, a little bit of roughness, probably a lot of roughness, and 0 height. Okay. Let's start by adding the divots, for example. So I'm just gonna make a new fill layer, and we'll call this concrete detail. And I just want this to affect the height for right now. We're working one channel at a time, height and the normals. A lot of black mass to get started. And then we'll add a fill of some kind. So right away, I'm just gonna kind of pop in here and look for some kind of grunge that I can use for concrete, right? I want a bunch of little specks probably, so we can kind of look through. So which one of these is gonna work for us? Not fingerprints, right? Maybe this one could work with a little bit of finagling. Marble veins, this one could work as well. So we can just pop this in and take a look at it. Let's turn the color back on, right? And I feel like this could work for concrete if we tweak it a little bit. So I'm gonna do that same trick. I'm just gonna turn this to red so we can see what we're working with. And I don't want these cracks and details to be the isolated spots. I want it to be the other way around. So just the cracks and details should be red when we're working with the height here. So I'm gonna go ahead and I'm going to add a levels, just so I can introduce you to what levels are doing. So when we're working with these masks, quite often we don't want these super contrasty values that are going all the way from 0 to 1, right? By default of textures like this one, I've just dragged it on, I've got values in 0 and I've got values at 1 side by side. This can be okay, but oftentimes we want to work a lot more minute than this. We're building up those small details bit by bit, not in huge chunks. So if I have this where it's just black, let's say I wanted to add a lot of height depth. All of this is going to just sink in astronomically, right? We want levels and layers to our stuff. So I'm going to invert this first and foremost so our cracks fall into our actual, where we have our cracks. And then using our levels, we can adjust multiple different features. Here we have input black and input white. At the bottom we have our output. Ooh. As you can see, if I raise up this value here, it's raising the minimum value of my output, right? So if it's at 0, then my texture will output 0, but if I start to move this up, the minimum brightness starts to become 0.2, 0.5, 1, right? And vice versa, right? My max output white, I might not want it to be white, I want it to be gray, I want it to be less, right? And the third one is this midpoint. So this midpoint is just determining where our half value is between our gray and white and what it's actually going to allow to show through. So in this case, I'm going to just raise up or raise down, sorry, our output white or input white here. I don't want all of this gray because then that gray is going to get that height detail that I don't want. I want this to be specific areas. So I'm going to just nuke this down a little bit until we're getting these sharp white areas. And then we just want to run, there we go, a blur on top of that to avoid these really sharp edges that are going to pop up. So under here we have filter. There's a bunch of built-in filters. And I recommend you get familiar with all of these filters and things like this because most of them, what they're actually built on is these things called Substance Designer nodes. So in the back end, these are running on these mathematical nodes that are used in Substance Painter and Substance Designer. We are going to be using Substance Designer down the line. If you get familiar with this process of building up different layers in Painter like this, like what I did with those bricks earlier, I could do the exact same process I did for the bricks in Designer as I did in Painter, and even more. So try to familiarize yourself with as much of these as possible because a lot of them will come up later. In this case, just use a blur, plain and simple. I don't want too much blur, 0.01 maybe. Just to sort of feather things in a little bit nicer. Okay, you can kind of see the difference here. So from here, I can kind of remove our color value. We have a pretty decent idea of what's going on, but we can lower our height value here to sort of start creating that detail. And I'm just going to lower it a tiny bit, not a ton, don't need a lot. Something like that maybe. Turn off the color, and now we're kind of getting some more of that concrete-esque detail. Okay, but we're not done yet. Of course, there's a lot more we can do. Let's add some color variation throughout and maybe some normal map detail on top of things. So I could add at this point, theoretically, an anchor point here. And we can use that later. So if I add an anchor point, I could use this mask to create color variation even inside of these little bits here. I think that might be a bit overkill for what we're doing right now, so we'll just go in here and turn on color, and we can add some color variation in those holes that way, right? Another quirk of the blending modes is it actually changes based on this setting here. So you have blending modes for every individual layer mask. On mask, it's easy because it's just the mask. There's only one form of blending. You're blending in black and white. But if I switch over to the fill layer here, and let's say I change this one to multiply, right, to get more dark details inside of these holes, you can see I'm actually on the base color layer when I'm using this multiply. If I switch this to roughness, it's going to change back to normal. So it becomes a lot because you're actually going to manage not just one blending mode, but each layer might have up to 5 different blending modes depending on the different things you're blending together. Typically, that's why we try to keep things separate. With this one only doing color and height, I know I only need to worry about color and height, right? And for height, we're just adding every single time basically, so I just have to worry about color. So we'll multiply our color in, and we can change this value a little bit. Right, and you'll notice the height is not changing even though I'm changing the value, and that's because, like I just said, we're only affecting base color right now. If I switch this to height, then it will start to affect it. So back to base color, multiply, and we'll just add a little bit of tinting. We really don't need that much. Okay. Now on top of this, I want to add some more detail to make this feel a little bit more like concrete. We need some larger elements to match the smaller elements we just kind of added here. So I'll just duplicate this layer and call this concrete height detail. I'll just reset everything. We'll put this back to normal, 100. And again, we're going to leave this as just height. Okay. I'll pop into my settings here, and where I had grunge marble veins before, we'll go pick something else. So I think there might even be concrete. I could just search up concrete and see if we get anything good. Concrete dirty. We can kind of take a quick peek and see how this looks for us. Not good. Maybe try something else. Let's get rid of our levels just so we get a better idea. Concrete moss, concrete paint leak. There's going to be all kinds of different textures built in here already, and if you're really not happy with any of them, you can build your own too. So let's go with this concrete paint leak, and this time I do want to get those gray values using the levels, right? I don't want our normal map to have these little peaks all over the place. I want it to be pretty well balanced, so we're going to adjust everything with our height blending. And instead, what we're going to do is just move up our output white and black to make them more in the middle. How do you actually know when to do this? It's a little bit hard to tell, but you can, I think you can, if you just Google height map, right? And you start to look at other examples of height maps, you'll see the things that I'm talking about right now. So a lot of these, they're not just like sharp contrasted black and white, right? There are a lot of like these gray values, a lot of the mid value with the ability to go lower and higher. If we start at a gray value for our height and we want to add, let's say, more height down the line, it's easy to add more white on top. and more black underneath. If we start with a mask that is black and white and want to add more height on top, we're basically stuck. You can't go higher than 1, you can't go lower than 0, so you're going to run out of range to work with very quickly. So something like this is fine for this kind of detail. Okay, we'll just pop into height, and I'm just going to do the opposite this time. This one I'm going to raise up a bit. And now you can see we're getting a little bit more of that detail in here as well. Right, so it has texture, it has a little bit of messy detail and noise. Now we can add some color variation. So I'll just copy it again. Concrete color variation. And we'll remove the height bit and just set this to something else. So we'll get rid of the blur and the levels for now. We'll just come back here and adjust. Right, just using the same mask as the other one, I could theoretically instead add a anchor point here. So if I ever make changes here, so let's do that just to demonstrate the uses. I can do it before the blur, so we'll just go add anchor point, concrete height detail mask, and then add fill here. Anchor point, concrete height detail mask. Okay, and it's going to do the same thing, but now if we ever change what that mask is, it'll still work. So if I go down here and decide concrete paint grunge isn't it for me, it'll still move my color changes over, right? So maybe this looks more concrete. Let's just roll with this. So next, we want to do the actual smart material stuff. This is where we get into using those masks. So we've got a good base to start working on. Now we can start thinking about like, oh, let's use our cavity mask to destroy this edge or add some dirt or whatever else. How far you go with the material is up to you. In the wood example I showed, I did literally everything. So everything from the base layer, which is more or less just this part, to a little bit of scratching, to thickness darkening, edge damage, extra edge damage, dust, grime, right? It's all built into one material. That might be a little bit excess for what you're doing. Maybe you want to do different kinds of dusts and nicks. The more simple you keep it, the more reusable it's going to be. But the more complex you make it, the less time you have to spend adding to it down the line. There's really no rhyme or reason to which direction you take other than this way is faster. That part's kind of up to you. So for me, I'm just going to build this up, and we're going to skip all the dirt and dust and things like that, but we will build up some edge damage. That's pretty consistent throughout anything that's going to use as textures. It will have edge damage. You might not have dirt and dust, but it will have edge damage. So let's build some edge damage. Can add another fill layer, just as we do. Again, fill layer, fill layer, fill layer. And another black mask. Okay. I'm going to hop into our mask view one more time and add a generator. So underneath generator, we still have access to that outdated mask builder. It is legacy, but it does still work 99% of the time. Granted, this is 2022. I don't know if this still exists for you or not. If anybody is still using this, if they could tell me if it still exists in 2025 version, that would be appreciated. If it is, I will use this because arguably it is much more flexible than the other ones. If it's not, then I'll just use the direct mask one, like the curvature one. Does anybody see Mask Builder or Mask Editor available? Yay, nay? To actually get to this panel, you have to add a generator first, and then under the generator tab, you can see it. They're both still there?
I don't know if I'm 2025. Hold up.
If you're using the one from the school, you will have 2025.
I am.
Okay, perfect. So arguably these ones are more flexible since they give you access to all of the different mesh maps at once, which can be a boon, but they are less efficient. So all of this, because it's procedural, it is still computing things. That wood material I made, though cool, because I've built up the entire material from base to dirt, it takes a hot minute to actually import it to a project and actually use it. It is quite slow, and render time is something to consider. So if you know you only need curvature, you might be able to get away with just using the curvature mask. In this case, just to kind of keep things simple, I'm going to use the mask builder so we can kind of go over what it does. So by default, it's already given us a not too shabby result, but we can do better. So in here, we've got our AO map, our curvature map, just like I showed before. We don't want to use AO for this. I'm just looking to create edge damage. So you can see as I get rid of this, it's getting rid of any of the areas that are using our AO mask, which if I flip over to the AO mesh map, right, this is our AO mesh map. Should look familiar. You should have baked one of your own by now, hopefully. So it's inverting this, and then it's taking anywhere that's dark, and it's adding grunge, right? Because theoretically, anywhere on your ambient occlusion that's dark, that's where your dirt and stuff is going to build up. So we'll get rid of this, go back to our mask, and I just want to work on edge damage for right now. I don't know why Discord's open, so I'm going to just get rid of that. So no AO, curvature all the way up. We've got a gradient on using the position. So this one is from front to back, adding a gradient with more detail at the front. I'm going to lower this quite a bit. We don't really need that much of this since we're mostly looking at the edge damage here. And underneath each one of these, you also have additional settings for each mask. So in this case, the curvature range, let's think about concrete as a material. It's not going to chip in like this pretty princess way where it's just like this tiny little streak along an edge, right? It's concrete. It's made to be sturdy. If it's going to chip along the edge, it's going to chip pretty hard. So if we make our concrete edge detail look like this, it's not going to look like concrete anymore. So we've got to bolster our curvature map with a little bit of extra help. How do we do that? Well, we have to adjust these settings. So we can up the contrast and the range to get a much larger, not this one, to get a much larger reach for our edge. So we'll just kind of keep going until we end up with something we like. Okay. Then we also have our world space normal being used here for things like scratches. So you can see if I zero it out, our scratches become very visible. Our scratches become very visible the other way. In this case, I don't want any of those scratches. They don't look that good, so I'm just going to leave it at 0. On top of this, our edge right now is super clean. This looks obviously procedural. What kind of edge wears in this kind of way, right? So let's just make this like bright red again so we can see what kind of edge is going to wear in this manner. Definitely not concrete, right? So let's flip this over here to our mask builder and go down to grunge. So we can overlay by default custom grunge. This is something we would have done anyway by just adding a second layer and multiplying it, but this is why the mask builder is kind of useful. We can pop in a bunch of grunges. So in this case, you know, I like clouds 2. So if I punch clouds 2 in here, we can start to adjust. Where'd it go? We can start to adjust our custom grunge. So now you can see it's using our clouds 2 instead of what it was using before. Okay. And that will affect our edges as well, right? It's just being multiplied into our edges. So let's go down here and sort of play around with our clouds a bit until we end up with something we're happy with. Oops. That's a bit much. Right, we turn up our edge a little bit. It helps. Okay. And then finally on top of this, I'm going to add a filter. And we have a filter called the blur slope, which is going to cut in a new texture on top of our existing texture. So there's a default noise, or you can use whatever. You can reuse a previous input. So in this case, if I reuse that previous input, it's grabbing that cloud detail I used to cut away at the edge, and it's continuing it into a blur slope. So this is going to be our best chance of getting a good result. If I go back, we can tweak this some more now that we have this other layer on it, and we can see how that affects things. Right? So boom, now we're getting somewhere. I'm gonna blur this just a smidge to hide our super sharp edges here and little cutoffs. So we'll go something like 0.01, 0.05, maybe a little bit more. And I just want to up the contrast. Okay. So now we have a much more organic looking, broken up use of our mask, right? It's still not perfect. We probably want to adjust this more to have it kind of feather into the rest of the mesh better. If it'll let me. Oops. Tiny little bit more. The actual numbers I'm using don't really matter that much. It's just about getting a good result. Looks a bit better. And then we can go back, and with our newfound mask, we can turn this into our damaged sort of concrete bits. So we'll raise the value here. Just gonna set this to lighten, because typically what's gonna happen with any kind of material is over time that material is gonna fade, and when we chip off edges and things like that, we'll end up with a newer piece of material underneath. So that's why our edges are usually lighter. If we have something that's black and we painted it red and our paint chips off, then obviously the edge is gonna become black. But typically speaking, with solid materials like this one, we'll end up with something lighter where we've chipped off. So let's take this now. I'm gonna set this to lighten or linear dodge and just kind of add, not a ton, but just a bit. Okay. On top of that, right, now we've got this color variation, but our broken off edge is going to have its own kind of detail within it. So I'm going to drop the height once again, and I'm going to up the roughness even more since it won't have kind of gotten any smoother. Right. This is a good base. We can always paint and stuff more on top of this, but let's do one more thing, which is just break this up. So right now, what you can see is our scratch and details, they're continuing between our two parts, right? So it's a little hard to see in some areas, but we've got scratches and things continuing between. That wouldn't naturally happen, right? Because let's say there was a scratch here and then this part broke off. How would that scratch continue? It has to cut off at some point. So what we're gonna do is just reblend this part in with its own height data and mesh, or sorry, normal map. So we'll just change this one to our edge damage. We'll add an anchor point after our blur slope.
It's at the bottom.
Yep. And then we'll add another one that we're going to use for our damage. Normal map. Set this just to height. Add a black mask like we have been doing. Add a fill also like we have been doing, and pick some other kind of detailed wear. So let's go back to our mask. Forgot to add our anchor point. If we set this second layer to multiply, it's just going to use our fill is in the wrong spot. This is the wrong anchor point. There we go. Right, so if we set this second layer to multiply, as we kind of know, all the areas that were white will get some kind of value coming through. All the areas that are black, multiply anything by 0, you get black, right? So now we have this kind of damage built into our edge. So we can do edge wear detail. Go back to our material and adjust this appropriately. Okay, so now we've got little chipped off bits where that is. We could continue to take this further. We can do an edge detect to grab the separation between the two, blur it, and then add some lightness. But let's just say this is a good base for now. It's been about an hour. So we'll say this is a good base. I'm going to take concrete worn. Right, we've done everything we need to do to build up our base material. I'm going to right click. I'm going to go down to create smart material. Okay, and boom. It's automatically going to update it. What it does is it creates a copy of it and puts it in your Substance Painter Smart Materials folder. So it's built into one of your root directories for Substance Painter, which is kind of annoying, but you can find it there and put it on something like an external hard drive and re-import it into a project when you're working and need it. So if I scroll up now, you'll see we have different options like projects and starter assets and your assets. And under your assets is where we're actually going to show up with the ones that we've made ourselves. So you can see I haven't really made that many. I've made a couple for different purposes. Here's one of the woods that I made from another project way back when. All right, and so I can just apply it and boom, I've got wood. Or in this case, we just made that concrete, so we can go ahead and drop that concrete on here. And now we've got one fully concrete meat mat. Right. And so areas like this, it's using the position, which is why it's showing up so much. We can always go back and tweak it though. If I go to the body, we can find our concrete worn that we just made, right? And adjust things. Another reason anchor points are so good is because this anchor point, it's translating and making sure it's using this one in this material. It's not grabbing an anchor point from the head because that would be a totally different mask. It's going to use whatever mask is built up from the layers below it properly. Okay. So if we want to tweak the edge damage just because we feel like it's too much, we can always come in, grab it, and just kind of tweak out what parts we don't want. So top-down gradient, there wouldn't be a lot of edge damage in here because it'd be hard to get into. Same with everything else. We can just sort of get rid of a lot of this. Okay, until you're happier with the result. But boom, we've made a smart material. Anytime I need a concrete smart material now, I can quickly just grab this, plop it on, and add other things that I might need. Maybe I want a little bit of moss on it. Maybe I want to tweak the edges a little bit. I can go in and paint that stuff out, but I've got something that's really decent looking and we can use going forward, right? I'd recommend you do this for your projects because it will help you texture things for GDW a lot, and it will help you keep things consistent between your team. When I was working for Gavin on Gladiotron, his game back when, one of my roles was to make smart materials. So I created a series of these materials that they could use as bases for any of the assets going forwards. That way, any time in the future, that project's been going on for like 7-8 years. I don't think it's ever coming out. But anybody that's using the project in the future or needs to work on it, he does student internships on it all the time, you'll be using my smart materials to keep your assets consistent with the ones that are already in the game. If you are making your GDW game, you, as the art lead, whoever you are on your team, should be building smart materials or things like that, or just base materials for your team to use to keep the assets looking consistent, right? If you go work at a studio like Ubisoft, they'll have a bunch of these already for a project. The art director will do this kind of thing ahead of time and get the tech artist to start building them. Keeps everything looking way better than a bunch of people struggling to make or copy each other's art style when you're just starting out as an artist, okay? So if you do have the time and you do have the experience, go start building these out, use them for GW games. They don't have to be realistic like this. These smart materials can be stylized in all kinds of different ways. If I go to there's a set that is called AIG Stylized Materials, for example. That I just happened to find online. You can see all of these, though being smart materials, they still follow that same kind of guideline, but they're stylized. They don't have like a ton of edge damage or anything like that. They're all built on top of gradients and stuff like that. You could go as far as to even do tune shading. So it's really up to you how you build these smart materials, but I would highly recommend going through your projects, going through your GDW games, building up an asset list, thinking about what you need, and then build some smart materials for them, right? Maybe you need a couple different types of metals to get started, and a couple different types of woods, things like that, okay? Any questions about smart materials, things like that? If you follow along with the example or watch the recording, you should have a pretty good understanding of how to build them. Yep. Not expecting you to do this necessarily for your assignment. You can build those up one-to-one because you're probably not going to be reusing a lot of these materials for your assignment, but it's an option. Yep.
Is it acceptable to like take an already existing one but edit it heavily?
Yeah, we'll do it this way. So if you pop a smart material on and I recognize it as a smart material, I will immediately just be like, boo, when I'm marking through them. Because I will recognize them. Believe me, I've got enough experience to do it. Tweak them, make them your own as you work through them, right? I wanted to show you this so you understand how they work. And so you can better understand how to manipulate the ones that already exist as well. Okay, but I do need you to manipulate them. Don't just drag them on, drop them, and be like, okay, I'm done. Okay, cool. So moving on from smart materials, now theoretically you've got a object, it is textured, it's UV'd, it's great, it's ready to go, you've made normal maps, you've made textures in Substance Painter. What do we do next? Well, we've got to actually render our object out. And there are a few different examples. They're not really in the slides, I'm going to just show you the ones that I think are most applicable. The first is do this. Sorry, well, the first is Iray. I'm showing Iray here in the example, but essentially, I don't want you to just screenshot what you've got in Painter. That's A, no good for submission, B, no good for your portfolio, and C, doesn't help you understand how to put this in your game and keep it looking actually properly good. So we are going to be rendering these out in some real-time format of your choice, whether it's Blender or Unreal, Marmoset, Iray, up to you. But it does need to look good. So just right away, looking at the differences, it's kind of hard to tell on the projector, right? But obviously, this one's very blurry, and this one is slightly less blurry because it's actually rendered out. You get a lot more detail and depth with the environment that you're creating. Something that a lot of the people do for the submission is they will just grab a screen cap, and that is boring. We want more than boring. So if I just pop into ArtStation real quick, we look at some kind of like product renders, right? This is the kind of stuff that we should be seeing. So it's simple, right? It's just you put it on the edge of a cube and added a shadow, but it's adding depth to the piece and the render as a whole, right? Putting two of them on a piece of wood, adding some kind of background props. This is really going to separate your work from other people's. These aren't just objects floating in space. They feel real. They feel ingrained in the environment that they're in, right? So let's look at some more that kind of do the same thing. This one, again, a different style and different approach to it, but all the best renders are still kind of doing this thing. So we do have this one where it's just floating in space, but it's followed up by this one where we've got multiple renders in this blueprint style look at things, right? We've got a breakdown render where he's separating the different components. They're still floating in space, yes, but we've got a detailed look at all the different parts, right? Here's a breakdown of the actual materials. Here's a breakdown of the textures and masks he created, right? All of the best render artists are going to be doing this same thing. Actually, let's do this one. Right, even if it's as simple as something like this. So this is Andy, old buddy of mine, helped me a lot when I was going through this program, but just something simple like this, where he's added Game Boy cartridges around his Game Boy, okay? So a lot of you are making like a 3DS or whatever, consider just making a bunch of cartridges, something to fill in that background, something to really help the object feel like it's part of the space it's sitting in, okay? He even went as far as to make an entire background of them to sit it on. Right. Having a few of these shots is not the end of the world, but they should not be your main focus. These ones are only here to demonstrate the technical aspects of things, right? So here's the wireframe and what it looks like, the back and the wireframe as well, the different orientation views with the wireframe, sorry, right? Even this. Lots of character, adds so much to the project that otherwise wouldn't exist. Okay. And then finally a Marmoset renderer. So we are expecting a lot more from you than just boom, screen cap. How you do that is up to you. So first, the primary way you're thinking of doing this might be Blender. I would highly recommend against it personally. Blender, honest, as you can tell by the screenshot, I don't render anything in Blender. I'll show you how to do it, but I don't really recommend it, honestly. It can be a bit of a pain. The other option is Substance Iray. So you're all using Substance Painter already, so you can use something called Substance Iray. It's a renderer that's built into Substance Painter. It is okay, but it is not great because you don't have a ton of control over things like adding other props and changing the camera and manipulating it easily. On top of that, you have Unreal, which is still loading for me, but it is an option that you can use. Probably I'll demonstrate it here. And finally, Marmoset Toolbag. So these are in order of how I would recommend rendering your stuff out, from Blender to Iray to Unreal to Marmoset. Marmoset, though, is not free. If you find it somewhere, again, I don't care, but it is typically, I think, somewhere around $300 USD range, I think is what I paid for this. This is Marmoset 3, which I bought like 5 years ago. I think they're at Marmoset 5 now. But anyway, this will get you the best results when you're rendering. If you're looking at all those product renders I just showed you, chances are they're in Marmoset, generally speaking. And the other advantage to Marmoset is when you're submitting, you'll also kind of be expected to submit like a Sketchfab 3D model version. Oh, I gotta pull up that link again. So if we go down here, Marmoset has a built-in viewer that is like Sketchfab, but like a million times better. So one, the render actually looks good, unlike in Sketchfab. Two, incredible options for evaluating different parts of the mesh. So I can check out just the albedo, get a good idea of what's going on, check out the reflectivity. If you're just learning and you want to examine other people's models, you can find these Marmoset viewers and see like, okay, what kind of values are we dealing with our roughness, right? So remember what I was saying, we don't want values just from 0 to 1. Our roughness map is sitting in a variety of values, mostly in the gray range, right? He's added fingerprint details on the buttons, things like that. And topology, if you're struggling with what do I need to add to my mesh, what can I just bake in, what needs to be done differently, right? So here we can see all of this little detail is just baked in. All of this detail is baked in. These little details, right? There's no geometry supporting a lot of that stuff, right? And here, same thing here. That is not real. There's no geometry. That is not real. These bits are broken off and they're super simple geometry, etc., etc., etc. So do make use of all of these features. If you are going to buy Marmoset, I can help you out with how to set all this stuff up. But for now, we'll use Sketchfab because it's free.
Marmoset is $400 USD.
Cool. It's even more expensive now than it was when I bought it. It is a little tough. Like I said, if you find it somewhere, finders keepers. Not in my business. But yeah, if you're looking to do this professionally for like life, it probably is worth it in the long run because it's also the best baking software. I do
like a monthly subscription to for like $20 USD.
Yeah, don't do that. Monthly subscriptions are bad. But it is the best baking software that's out there as well. So all of my mesh maps that I showed you how to bake in Painter here, I don't ever use this baker. I use the Marmoset one because it is 10,000 times better than this one. Again, really up to you. If you want to do this for life, I'd recommend picking it up before it gets even more expensive, but also your students. So that's a lot to ask of you. I'm not expecting you to, obviously. We'll go through the other options for rendering as well. What time is it? 9:26. Okay. So we got an hour and a half. Do you want to take a quick break before we get into the rendering bit, or just kind of power bomb through it and then get out of here at like 10:30?
Power bomb it, please.
Powerbomb.
All right. We'll just kind of run through everything then. So let's start with Blender. Now I need a project to actually render, so maybe I'll just use this meat mat right here. Let's start with rendering in Blender. Every program that we use is going to render things with their own internal shaders. Blender has its own shader. Unreal has its own shaders. Marmoset has its own shaders, etc., etc., etc. So for every program that we're going to export this to, we need a different set of textures. Some may use combinations of textures. If you're working in Unreal in a project that's already been built, they might be using what's called the RMAO workflow, where they have a bunch of the different textures compiled into one. If you're working in Blender, Blender uses OpenGL normal maps instead of DirectX, so it needs to be different than if you export to Unreal, which is using DirectX normal maps. So just to start, we're going to use this meat mat here. I need to export the mesh first because I don't actually have the mesh, so I'm just going to export the mesh. To my desktop, just so we can actually use it in our scene. So let's import our mesh. FBX, desktop, and meat mat. Okay, fantastic. So Matt is tiny at the moment, but he does fit in our scene. I'm gonna just make him a little bit bigger. How big is he right now? Oh, very small. Okay, let's just scale this up 100. Nope. 10. There we go. So our mesh is good in here. It's come with a bunch of different camera views, but I'm gonna just delete those. We just want the mesh. Okay. To actually apply our materials to this, we need to create a new Blender material, which is built on the Blender shaders. So by default, you can see we've got head, body, and base, which is what they're all built on, each with their own respective UVs. So I'm gonna hop over here to shading, and this will give us the start we need to start actually building our materials. So again, I do apologize. I'm not super familiar with this stuff since I never render in Blender. I'm sure it's decent at it, but it's not really my cup of tea. I need to grab the textures now that Blender can use. So if we go in here, we have the principal BSDF. This is our Blender standard something shader. And you see we have a few different values that are working with. We're working with the base color, the metallic, the roughness. We have a normal map spot, but we don't have like a height spot or anything like that. So we're just going to be using base color, metallic, roughness basically. Okay, so we're a little bit limited here. But let's go into Painter now and export these materials. So another reason why I always suggest not having multiple of these is I now have to export 4 textures for every single one of these. 4 for the head, 4 for the body, 4 for the base, right? Not great for texturing for games. But we'll just roll with it since that's how the default thing is set up. Let's go to File here, and you'll see there's an option for Export Textures. And we're given options to export all of our different material groups, so in this case head, body, and base. And I'm just going to make a new folder on my desktop so it doesn't get too out of hand. Okay. And then underneath we have output template. So there are a few different templates that exist already, right, for us to choose from. We might have to tweak some of these later, but we can get started by just clicking Blender, and that'll give us a decent idea of where we're at. So I'll click Blender, I'll click PNG, 16 bits is fine, and we can pick a size as well. In this case, for all the texture sets, they are 2048, let's just go with 2048. Okay, that's it. I don't want to export USD asset, I don't want the mesh, I just want the textures. We'll build up the material and our other thing. Next, we go into output templates. Now this part's pretty important and a little bit confusing unless you're familiar with regular expressions. But basically, this is what your textures are going to be named. It's not too important necessarily, just know that you need to pick the format that you're using. So in this case, Blender. And then I'm going to go base color, normal, metallic, roughness, emission, alpha, and displacement. So it's got all of those different settings built up. Usually what's going on in our engines, like if I go to Unity, for example, you'll notice that one of these has a bunch of these different things laid out. On our left, we can select our presets. In the middle, we have our output maps. So in this case, we're actually outputting 4 maps for Unity HDRP. And over here, we have the color graph that tells us what map is going into what channel. So is anyone familiar with the idea of channel packing? Does that term ring a bell to anyone? No? Okay. So in order to save space when we're working with these textures, a lot of them don't need to be in a texture by themselves. For example, the roughness map. The roughness map, all of our values are from 0 to 1, right? Remember earlier when I was talking about blend modes, how we multiply things together 0 to 1, but if we work with colored maps, we're multiplying everything together in the red, green, and blue channels? Because each one of those channels is its own 0 to 1 range, we can put an entire roughness map in just the green channel of a texture. Height map, also just black and white. We can put the entire height map in just the blue channel of a texture. Metallic, also black and white. We can put that entire texture into just the red channel. And we end up with a texture. In this case, they call it mask map for Unity. It differs depending on your project and how you want to get it set up. But I've got a red channel. You can see the R for red channel on this texture. And it's this yellow color that matches up with our metallic input map. So the red channel is going to be our metallic map. Green channel. You can see, in this case for Unity, it uses mixed AO, but you can tell because it's using the same channel mode. And then the B channel is using the glossiness. Or sorry, it's not. The B channel in this one's not being used, I don't think, and then glossiness is going in the alpha. Right? You can hover over to be sure. So here, alpha, there's the glossiness. Right? All of those maps that are grayscale, we can channel pack. So this way, when we're exporting to our engine, instead of exporting 4 textures, we can just output 4 black and white textures, 1 to each bit in our color texture. Okay? And then within our shaders and engine, we can break those up and use them in the places we need to. For Blender, this isn't really a thing. As you can see, there's no channel packing. Because Blender is not real time, we don't really need to worry about the amount of VRAM we have available, so having umpteen textures per object is less important. You'll notice though, for all of the Unity ones, we're channel packing at least something, and same for Unreal, we're channel packing at least a few different things, right? I'll explore that a little bit more when we actually open Unreal and go from there. So for now, let's just go Blender. I'm gonna punch that in. We can see all of our different textures. It's going to output the name as the texture set name, which is whatever you have up here. So that $sign texture set is just an expression that represents whatever the texture set is here. So $sign will let you access the variables. So in this case, it'll export 01 underscore head followed by underscore base color. The color space, which in our case is sRGB, I think. So it'll put that there, and then .udim. We don't have any udim, so it'll just leave that blank. Okay, you can see here the different variables we have to name our things. All right, let's export these, right? So all of these different ones per material. This is way too many for a game, but for what we're doing right now, it's okay. And let's export these to that folder. 21 textures exported. Just gonna hit save, close out of here. Now that we have those textures, we actually have to build up the shader that's using them. So by default, we have the BSDF. We don't really have to build up that much. We're just inputting our textures. In Unreal, we will have to actually build up the shader from scratch. But here, we've got a normal map converter. Let's just pretend this doesn't exist so I can show you what it does. Right now, we're on the head material. So up here, we have head, body, and base. And we need to import our textures. So I'm going to go ahead and add a texture input. Texture, image texture. And this is going to open an image texture node within my shader here. So for this one, we'll hit new, or sorry, not new, open. And we'll kind of go in and pick our materials. And I'm just going to grab all of them. And if you mass select them like this, it'll only pick one of them for this, but all of them will become available as references in your Blender file, so we can quickly scroll to them later. So we'll start with head base color. And this is a color map, so we're just going to take this yellow node, which represents color data, whereas the gray represents grayscale data, and we'll just plop that into base color. So boom, now we have our base color. Great. But our object is very shiny. which is not how concrete is supposed to be. And that's because we haven't added our metallic map or our roughness map yet. So right now the metallic map is set to 1. I can drag this value as a whole, right? We know that there's no metal in this texture, so theoretically we could just do this and call it a day. But we have the metallic map anyway, so we might as well use it. I'm just gonna grab this. Whoop. I'm gonna duplicate it with Shift D, just like as if we're duplicating things in Blender. It works the same way here. And then I'm gonna drag the color from our metallic map here, so make sure it's the same one. So head material metallic color, which isn't really color, but we'll drag that into metallic. Okay. For this one, our color space is sRGB. We don't need sRGB for this one. This one is grayscale. So we'll just pop through, and I don't actually know if there is a grayscale option here. Is non-color Blender's version of grayscale? Maybe. It's just a black texture anyway, so this one doesn't really matter. All right, so we've got our base color. We've got our metallic. We're going to Shift D this again. And we'll switch this one to the normal map. So if I double click on a node, it'll pop up the texture here as well to take a look at. So we can have our normal map with all of our little details. But you see the normal map actually takes a purple node. So we can't just drag and drop our color into our normal map or we'll get some crazy result. So we have to drag our color into a normal conversion node. Normal map. Okay, this will take our normal map in and export actual normal details that we can use on our mesh. So now you can see our normal details are starting to shine through. One thing I need to check is this is using DirectX, it looks like, for this project. But when I export, because I use that Blender template, we just want to check real quick to see if it changed that. Yeah, so right there. You can see it actually, even though our project is working in DirectX and Substance is rendering in DirectX, when we export to Blender, we can set to export as an OpenGL map because Blender uses OpenGL, right? We'll have to do the same thing and check for Unity and everything else down the line. So boom, we know our normal map is good and it's good to go. Base color done, metallic done, normal done. Now we just need our roughness, so I'm gonna do the same thing again, just Shift D, change this from normal to roughness. Drag our color in. And again, I'm pretty sure the Blender version of linear is non-color. And there we go. So now our material is built up in Blender. Right? You could go through and do all this other stuff, but we don't have any of that on our material, so we're good with just this. If we really wanted to, we could add that displacement map, which will kind of increase the detail on our normal by changing the actual height if I actually exported them. So here we have displacement. We can double click it. We can see this is where all of our little height details came in. They replicate themselves in the normal map, but we can also use this here. Oh, maybe not. It's just drag this in here, drag this in here. Okay. By default, super aggressive, so we can just kind of lower it. Not this. Okay, and now we end up with more or less the same kind of texture we had in Painter. All right, now for the fun part, doing it again. So, because how Blender works, every material, right, you're building up its own shaders. So, kind of a pain, but instead what we're going to do is just kind of plop all of these onto the same material using Control L, link materials. And by default, it's using the O1 textures. So now we're just going to flop through and do O2. So, O2 base color. This is metallic, so we go O2 metallic. This is O2 roughness. You guys shouldn't have this problem because you should have just one material for your object. This is just because of how it was set up for this demo. And then this one is normal map, so O2 normal. And O2 displacements. Cool. Whoops. I accidentally made them all, yeah, you caught that. Yeah, I made them all references of each other by accident. So, sorry, same thing, linked them up so that it copies it. And then when you click the body, I'm gonna click this little 3 to make it an actual user. So now it still has all of this stuff in it, but it actually is gonna change just this one texture. So, same thing, again. O2 metallic.
You're changing the heading.
Is it?
Just the head, not the body.
Why is it doing this now? Why is this using body now? Head. You. Click. Delete. Head. Okay. Anyway, you can see why I don't use Blender for this stuff. Body roughness. Body normal. Body displacement. All right, third time. Change this. Double check that they're all different. All right. This is O3. Base color. O3 metallic. O3 roughness. And O3 normal. If you use the same setup in a game engine, you would be sitting here doing this exact same thing. So make sure your material setups are proper. Displacement. Okay, there we go.
Pretty sure when you chose a different roughness map, it changed it from non-above back to RGB.
Does it do that too?
Yeah.
That's so dumb. I'm going to assume the bits are just fine, honestly. I don't feel like changing that again. But it's generally set up now, right? We have our material. If we go into layout, we can take a peek at it in material preview. Wow, fantastic. All right, great. We have our displacement. It looks good. It's normal mapped. Fantastic. Okay. So I'm just going to be in material preview mode for now. If you're not sure where that is, you just hit Z and go down. I'm going to build up a little scene that we can use to add some shadows and just better lighting for this thing. So if you want to just make the most bare bones scene possible, what you can do is just make a plane here. I'm just going to grab one end of it and extrude it up. And then just bevel this like a ridiculous amount, just as a nice smooth backdrop, as if this was like a product render, right? We can kind of just plop this in. But it gives us a nice place for our shadows to land and things like that, right? Rendered mode, nothing's happening yet. So let's go in here, and I want to add a camera that we can use for our render. So let's just say we pick a good view, maybe something like this. Hit Control A and add a new camera. And then we can kind of move it into place. Wonderful. Okay. So in render view, there's still not a whole lot going on. We can adjust our camera's focal length and everything like that. You might want to, depending on your prop. In this case, it's fine. It looks a little isometric, but it's okay. And we need to start adding some lighting as well. So a very easy lighting setup we can use is just a 3-point lighting setup. I'm going to go ahead and go to light. And the first thing I want to do is just add a big area light. I'm going to try and avoid directional lights for this because that can kind of be annoying. And we'll probably add some kind of, what's it called? HDRI to this after as well. So we'll pop into rendered mode, we'll add our first light, and this is going to be our main light, quote unquote. So we're gonna make it quite big and just sort of up the power of it. We still want it to be far enough away that it's casting pretty soft shadows generally, and we want it to mostly highlight the front of our objects, but not entirely the front. We still want to have nice shadows and areas that demonstrate both the hard and soft edges. We'll just bump this up to like 200. $250. Okay. Beyond that, I'm going to just kind of duplicate this now. And this second sharp light is going to be our fill light. To sort of just fill in our lighting a little bit more, hence fill light. So I'm going to change this guys from 1 meter to something like 0.4. So it's going to cast a much sharper shadow. And kind of fill in our lighting. Okay, we end up with nice gradients all along this because we have our plane here. Take a quick look. And then the last one we can add is a rim light, which is always nice. It's like the last part of our 3-point lighting setup. In this one, it's going to be a little bit weird. Because we have this backdrop behind it, to add our rim light, instead of pointing a light from behind like you normally would, I think I'm going to try something else. But we'll try this first and see what it looks like. Go to our camera view, kind of move our rim light around. All right. Until we're kind of happy with what we got. So sure, let's just say this is good. Okay, if I turn off all the overlays now, we can see what our render kind of looks like. And for Eevee, it's not terrible, right? We can change this to cycles and take another look at it. Or does that break our materials? Okay, it's taking its sweet time, but cycles is doing its thing. And we're ending up with some form of render, right? That didn't take me too long to set up in Blender. The majority of the time was just building the stupid shaders, but oh, I'm using my CPU, that's why. Oh, way faster. Yeah, so you could do something like this in a very short period of time. It's just a few different lights. If I wanted to spice things up even more, I could always come in with like point lights or change the values of these to make them lower, add a few more lights to my setup. I could tweak the color of these maybe a little bit. Maybe that's kind of boring, so I want to go with like there's something called the like warm, cool lighting setup that's very generic, but it does make things look good. You'll see it all the time where you use a combination of cold lights and warm lights. Where the warm lights typically are going to be in the front of the scene, and as the scene gets further back, the lights will get cooler and cooler. So I can replicate that kind of easily here by just popping into, we'll go to material preview because I'm tired of this lagging. Turn on our overlays. So our rim light is theoretically further back in the scene. We'll kind of just move this to a cooler hue, and we'll take our main light here and move this to a warmer hue. Not a lot. The way light works and our base color should be pretty unsaturated. I've mentioned this a couple times as you're texturing, but because it's so unsaturated, the light is going to do a lot of the lifting. So when we go to our render with this kind of setup, right, it's changing the color value quite a bit from our gray, from our original gray, even though we've only added just the tiniest amount of tint to our spotlights here. So let's add just a teeny bit more maybe. Make it a little bit more red, orangish, and the backlight a little bit more blue. Okay, and we've ended up with something pretty nice. As far as actually rendering this out, I'm pretty sure you hit Control F12. It'll render it out, in my case, in cycles, and boom, we have something that doesn't look terrible, right? Way better than you making a screenshot in Substance, okay? But not as good as, say, what we can do in Marmoset. It's going to be very slow because rendering in Blender is quite slow. Let's just stop this here and then use that. So now we have this render result. We are not just going to necessarily stop there. On top of that, if we pop over here to compositing, we can add filters and stuff on top of our scene. I'm not super familiar with the compositing nodes. I've probably only used them like once or twice. What I would recommend doing, honestly, is just taking that image that you made, so in this case, that render, and just popping it in Photoshop and doing all your touching up there. Add a little bit of sharpness filtering, a little bit of color correction where you need to, etc., etc., etc. Okay, so that is the Blender method. Any questions there, / anyone actually planning on using Blender for rendering or what? Maybe? Yeah.
Did you set the normal map's color to non-color?
No.
It cycles, from what I remember, does not like anything but non-color for normal maps.
That is unusual, but that probably explains why this looks so flat in cycles, because it looks fine in Eevee. Yeah, so, but honestly, you could just render in Eevee too. That is really weird because they are very much color data. But anyway.
Yeah, I don't know why cycles is.
Yep, Esmond.
Is there a significant difference to render like Eevee and
Yes, like a ton. I don't even know where to start, honestly. So Cycles was the original one that was made. Well, that's not true. Originally, I think we had Workbench way back when I started using it. And at the time, they were developing Cycles for Blender 2.8, I think it was. Anyway, they're based on, it's not ray tracing, but it's like something in that vein. It's compositing over and over and overlaying the details on top of one another. So it samples the scene using rays. Which is why if I switch to Cycles, you get this like grainy, slowly building up effect. Is it sending out all those rays, sampling the scene, and then just doing that repeatedly. So it just did it 4,000 times there. Eevee is more like a real-time engine. I think it's deferred. I don't remember if that's true. If anyone knows, correct me. But I'm pretty sure it's deferred the same way like Unreal and Unity lighting would be deferred. So it happens all at once. It renders the entire scene in one pass. Way faster. As you can see, I can just move the scene around and everything is still rendered, and you get a little bit of spottiness and sampling when you're moving around with lights in rendered mode, but generally speaking, there's no lag, right? It used to be that Cycles looked significantly better because of the way that it was built on tracing, but honestly, these days Eevee has gotten so much better, it's kind of scary. It's hard to tell the difference, even though it's real time. If you were going to choose between the two, Eevee is easier to use, mostly because of that shader. So that shader I was showing you here, this is an Eevee shader. Because because Cycles is a different renderer, it is technically a different shader if I switch Cycles. They might have changed it so it uses the same thing, but in the back end it is working differently. It used to be that you had to make an entirely different material just for Cycles, which I think, yeah, it looks like it uses the same for both now, but there are still some quirks. As Lucas just pointed out, it doesn't like normal maps with color data for some reason in Cycles. But yeah. For your rendering, I don't care which one you use. If you feel like Cycles is enough for you, then go for it. All right, if you want to use Eevee and keep it quick, go for that. Something else you can do is once you have a scene like this is just adding, like, if you want to do a black scene like this, so let's say I take away my backdrop and I just render this out like this. What I'd recommend you do instead is go to your world settings and change the background to pure black. So that when you render it out, you have something a lot more flexible for kind of, you can go in and mask this out in Photoshop or do something different. I don't know if I still have this old project up, but when I submitted my observational model, I kind of cheated because I didn't want to use a bunch of these extra props and really make my scene super fancy. So I just went and grabbed some fire textures and slapped it all over. I don't think it's visible anymore though. I gotta dig for it. Right here, for example, I just took a bunch of these random fire textures and put it in Photoshop, and that was my background. So I put that on top of the black background, and that way it just looks way more visually interesting than it would have otherwise, even though it took me 2 seconds of work. It was like no extra work. I don't know if you can actually see it, but there's a bunch of little like fire particles. Or can I do this? Yeah. All right. So this fire background, silk song looking background, like I just kept it in the Photoshop file and just laid my image on top every time, and then just use the magic wand to cut it out from that black background. Or you can use green. That's easier probably to cut it out. Right. So this is the kind of thing I'm expecting from you guys as well, because it's simple and easy and takes like 12 seconds. So if you don't do it, it's just kind of sad and it doesn't look as good on your portfolio. Okay, so that is Blender. Cool. Moving on from Blender, which, you know, again, not the end of the world, much better than it used to be. But if we want to move on from Blender, let's try something else. So this is Iray. This is arguably the easiest because it's literally built in. But if I go up here to where our option is in Painter, we also have Iray. So if I just click this, it's going to open up my render view, and boom, it has stuck matte in all its glory into a basic scene that looks a lot like the scene we just built in Blender. Two issues with this. One is that this is not representative of what it's going to look like in your final kind of engine. For a project like this, where I'm specifically asking you guys for renders of your observational models in the highest detail possible, I don't mind. But just note, if you're using this for like evaluating how something's going to look in engine, it'll look different. Just due to the nature of, this is not actually exporting these textures, right? They're not being compressed at all. They're not doing anything. They're just being slapped right into the Iray renderer. It's all behind the scenes. You don't have to think. You don't have to do anything. You don't have to make any, compromises. So it won't always look the same here as it does in other places, but it works more or less the same. I can use Alt and click to scroll around. It's built on ray tracing as well, similar to Cycles. So you can see it's doing that whole sampling thing every time I scroll around. I should say ray trace samples, not so much ray tracing. And it looks good as well. But the issue is I have so much less control here. So in Blender, I had the ability to add different lights and create that kind of warm to cool backdrop. Here, we're much more limited. I can go in and turn on post-correction effects and change the color correction, maybe make it more saturated. I can go in and change the environment map to change how my lighting setup is based on the HDRI. So in this case, Autumn Forest, or maybe whatever this one is, or this one, right? So I am getting a little bit more control, but still not nearly as much as something like Blender or Marmoset or anything else. So let's look at, let's go back to Studio Tomoko, right? If I hit Shift and right click, I can move the light around. So I can quickly kind of move my one big light into a nice spot where I've got a nice fill, but some nice shadows as well. And you can see by default in this scene, it's also using the 3-point lighting setup that I just built. So you can see the 3 shadows. Oh, you can't on the projector really. But there are 3 shadows, you just have to believe me, one here, one there, and one there. It's replicating the same 3-point lighting setup I just kind of built. Okay, I can tweak the exposure, whatever, the rotation, the alignment, but there isn't honestly a ton more you can do here. Right, maybe I'll make it sepia again. Okay, but I can't move the lights in the scene. I can't change the color of the lights. They're just built on the HDRI. It's very limited in that way. Okay, if I turn off this, you can see the HDRI in the background. That's actually lighting our scene. I would recommend turning on these 2 features if you are going to render an Iray, because it just helps ground everything and have it feel real in the scene. I wish I could show you more for Iray, but that's literally it. That's all of it. If you've been following along for the last 10 seconds, you've learned every feature available to you in this version of Iray. Maybe it's slightly different in 2025. They've added more features, but as far as I'm aware, it still is like this. It's built for previs more than anything else, but I'll allow it for submission because it does get you a good result. Once you have something like this, I'm pretty sure, yeah, you go into the renderer here, you can pause and turn it on, or you can go down here and save render. Again, this is in a render engine. Don't just take a screenshot of the render engine. That's not what I'm looking for. I need the actual render saved. So I can go 1920 by 1080, save render, put on my desktop, name it render. And then, why would I want to open it in Figma? And then open my render nice and proper, okay? With as much detail. And I could have upped this. I wouldn't go higher than 4K. You really don't need that, but you can go like 2K and your images will look super clean and crisp for submission. And because you're submitting in a ArtStation style portfolio format, you're gonna need a few different renders. So grab one of an angle like this maybe, and then switch it up, hop back in, kind of change your camera angle somewhere. Okay, and hit it again. This time, this view, render 2. It'll do a bunch of iterations and then save. And now I can also add this one to my portfolio style submission. Okay, any questions about Iray? No? Okay, probably don't use that one. Unless you absolutely feel like you have to. Last is Unreal, and this one is a bit of a doohickey. This is going to take up a bit of time. I don't know what this project is. I'm just going to hope it opens, because if I make a new one, we're going to be here for the next hour just waiting for it to load. So hopefully this one we can use. So because it's built in Unreal this time, we need to re-export our textures once again. So I'm going to pop into my folder here, Meet Matte. And I'm going to make another new folder inside of this and just call this one Unreal Textures. Hopefully you only have to do this once, but again, this is just the way it's set up. We might have to take a short break here, not by choice. I didn't think it would take this long to open, honestly. This isn't I'm using 5.2 mostly because the newer versions I find tend to break and the older versions also tend to break. So I either use 4.27 or 5.2. Do you guys know what engine you're using to build your games yet, or no? Yeah? Are people going with Unreal 5 or Unity or what mostly? Unreal? You guys are using, okay. Is that the majority, do you think? Like, have you seen a GW class, the majority of people are using Unreal, or?
Yeah, we get bonus marks for doing it. So.
Okay, gotcha. It is tough. It's way harder to use Unreal than Unity, but the payoff is probably worth it. And yeah, all the stuff I've taught you is mostly leaning towards Unreal anyway, and we're going to be using Unreal for environment art stuff starting next week. So while it's waiting, I guess we'll export our textures.
Didn't you already export it, or do you need to re-export it in the Unreal file?
Yes, I exported them for Blender.
Okay.
So now we need to re-export them for Unreal. Right, because it is going to be different. So if I pop in here now, by default we had it at Blender because that's what we're using it for. I'm going to scroll down until I find Unreal Engine, and in this case it's Unreal Engine 4 because my thing's old. I think you guys should have an option for Unreal 5 because your thing's newer. And I'm just going to plop this into my Unreal Textures folder. Let's take a look at what we're actually working with here. You can see it's only actually exporting 4 textures, not 7 like the last one. Okay. By default, with our Unreal texture, we're not using displacement. Okay. Our default Unreal export is not using displacement. That height map detail, we are going to lose that, but that is extremely computationally expensive. We don't need height map for such a small prop in Unreal, so it's honestly better that way. We're using the packed one, so we only actually need to export 3 textures. And you can see here we've got the occlusion roughness metallic. Occlusion roughness metallic. So that's going to be all of our textures in one RGB map. All of our black and white masks. This is kind of a side point, but something you should also know. Just gonna throw it out there. Does anybody know why we put our roughness in the G channel? Yeah.
Because like I think on Unreal it kind of affects the lighting of the specific engine, so it would make sense to just merge metallic and roughness at the same image.
Oh yeah, no, for sure. We do this because this color texture, it's like RAM footprint. It's going to be the same as just one other color texture. If we have 3 textures, then our footprint is way bigger, right? So we combine them for sure. For real-time stuff, it makes sense to do that. But the reason we use the G channel is the way that the other places handle compression. So when you compress these files and put them in engine, things like that, for whatever reason, there is specific reasons, I don't know the exact math behind it, but the green channel is going to be compressed less than the other 2, just by a small margin, but it is a small margin that can make a difference. So whatever channel we have the most important data in, which is typically going to be roughness, we're going to put in the green channel, right? We know about metallic, it's just a black and white mask 90% of the time, right? We don't need a lot of detail for that. Ambient occlusion, same thing. We can easily blur that in engine and get a nice result, or use the engine's built-in ambient occlusion to sort of supplement our maps. Roughness literally is going to make or break how our object looks in different lighting scenarios. So almost every single time, we're going to put roughness in the green channel. Red and blue, it's really up to you. You can do whatever you want with them. You can make your own custom masks. So one of the options I have here, and we'll learn about a little bit later when we do RGB masking. Quite simple. But this is one of the templates that I made, and we'll make it ourselves when we do our environment stuff. But this one is literally just an RGB mask so that we can do procedural details in our engine shaders, right? Because we have to build up our shaders ourselves. So you can export literally anything you want, any texture stacked any way you want from any of these options. And there are a ton. So you can see here, user 0, user 1, and 0, 2. I've just made custom maps to hide and put these different elements in. So go back to Unreal 4 packed. This all looks good. List of exports. You can see we have 12 textures instead of 21 like we did for Blender, which is much more effective. And we're halfway there. So I'm going to go ahead and export these now. It'll export our 12 textures, all in 2K. We can save, close, and let's take a look, actually. Here's what we'll do. We'll examine that mask map, that combined map. So I'm going to open Photoshop, I assume I have installed. And we'll take a look at that combined texture, piece by piece, and hopefully that'll, if you're not understanding what's going on there, I'll show you. All right, so here's our combined mask, right? Looks kind of goofy on its own. So just open this up. Let's go with the base one, looks the most interesting. Okay. So here is the base. There we go. Hello. Here's the base of our texture, right? And it looks a little bit funky on its own, but we can check our different channels here, right? By default, we've got red, green, and blue enabled, but if we look at them one by one. So the blue channel, right, we know is our metallic channel. And it shows up as pure black, just like our metallic map. So if I pop into Substance Painter now and we go to our mask, or our metallic, sorry. Right, our metallic is just pure black, as we expect. Next, let's look at our roughness. right? So if we look at our roughness texture here, let's go to the base because that's the one we're using for example. We end up with these black and white values that we're going to shove into our green channel. So when I turn on the green channel now, just the green channel, we've got our roughness export. And the red channel, same thing, but this one is whatever is in our red channel. So let's just go back, export. Our red channel is our ambient occlusion. So roughness, ambient occlusion, and metallic, they're all packed in one channel at a time into our one texture, right? And we end up with this weird looking green texture. In our actual Unreal shader, we're going to split each one of those channels off and put it in its respective place in 250 shader compilation time. Any questions about this stuff at the moment? Or are we all pretty good? Cool. Again, if anyone submits screenshots of, like the absolute worst thing you could do is submit to me a screenshot of your painter file that is just an object covered in smart materials that you did not adjust. I will crash out. All right, we have a project. Wow, look at that. Let's get started. So, welcome to Unreal Engine 5. Oh, this is my project from 2 years ago for a different class. So let's see if there's just an empty map we can use. Cool. So by default, I've got the advanced lighting option in Unreal 5. You'll all have this option if you use the built up examples, and you can see it's using an HDRI and some lights. We're going to build essentially the exact same scene we just kind of built in Blender, but we're going to do it in Unreal instead this time. So let's pop into starter map and we'll do it from scratch as if there's nothing here. This is not from scratch, never mind. Okay, from scratch. So we've got a bunch of clouds and everything else that's going to kind of help us out as we get into our lighting, but first and foremost we need to import all of our stuff. So I'm just going to pop in here, we'll go into props, sure, and I'm going to import my mesh. So we'll go find meet mat.fbx, boom, import, and make sure I set combine because I don't want them to be separate pieces. I do not want to create materials for this, and I don't need to invert the normal maps because we're using OpenGL. I just want to make sure combine meshes is clicked off, import. And we have that. So let's drag them into the scene here. Perfect. I'm going to put them at 0, 0, 0. And then I'm just going to set a scale to 10. Because of the export settings, it does get messed around a little bit and makes them really small. So we'll just set the scale to 10. I'm going to add a new object here, and we can build whatever kind of scene we want, which is great about this because it's Unreal. For demonstration purposes, I'm just going to pop in a cube here. Make the cube quite big, and then we'll kind of plop it at his feet. Right, so kind of like that other render where we had that guy's product just sitting on the corner of a cube, we can do something kind of similar, right? So my computer is lagging because it's Unreal. I'm going to start by just kind of nuking this light source, right? Everything's going to be dark. Let's go in and add a new one. And again, I'm replicating that exact same setup, more or less, right? We can just do a 3-point lighting setup. So we'll start with our fill light, or our main light, sorry, just like we were. right? Our main light, our goal is to get a nice combination of lit parts and shadow. I think it's a little bit too bright. I'm gonna darken it a little bit. And I'll quickly kind of pop this over, rotate it, make it much smaller so we get sharper light, 32, 32. And I'll make this a little bit lower. Right. So this one is just going to help fill in the gaps that our main light is not hitting. Let's move it further back. Great. And then last but not least, I want to add a rim light. So I'm just going to have a light coming in from behind here. And see if we can pump this up. So we end up with something a little bit sharper around the edge. So we can lower this quite a bit more. And move it in. Okay. Now there's something else we can do here. I'm adding my rim light because I want to get this nice shining edge around my object. But adding the rim light also creates this super sharp edge here on my block that I don't want. In Unreal, we have these things called lighting groups. So, group. Do we not have things called lighting groups? Channels. Okay, they're called channels in Unreal. Sorry, my bad. So by default, you'll see if I go down here on my light, I've got these options for lighting channels. This is telling it what it should affect and what it shouldn't affect. So every light you add in the scene doesn't actually need to affect every single object. You can have different groups. For example, if you're making a third-person game, you might want a bunch of lights to affect the player character, but not the actual environment around them. Maybe you have a permanent light that sits above the player's head just so they're more visible within the scene. You can use a lighting channel so that that light only affects the player for the entire game. Okay, maybe put on like layer 2. We only have access to 3 in this version of Unreal. I don't think they've even added more. I'm pretty sure 3 is the limit. It does get kind of costly. But in this case, I'm going to take this one off of 0, and you'll see it just immediately stop lighting everything. I'm going to set it to channel 1 only. Okay, so this light is now only affecting channel 1. So if I go to my mesh and find my lighting groups on here, lighting channel. Okay, lighting channels on my mesh. I want it to get light from both 0 and 1. So you can see now I'm getting that rim light that I made without actually affecting the rest of the scene. So that way I can leave this block kind of how it is, and I can still have my strong rim light. Okay, or if I didn't want this one to be affected by any of it, I could put it on 2 and add a second light just for the ground. Or in this case, what I'm going to do next is add a little skylight here. So let's get in here to add a new one. And we have this nice HDRI environment that's outdoors, so I want to make some use of that. So I'm just going to go ahead and hit a new light. Skylight. Okay, and the skylight is going to use whatever skybox you've got enabled at the time, which in this case this one doesn't because there's no directional light, so I just add one of those as well. Okay, and I'm just going to turn this directional light down quite a bit. Or I can even put this on channel 2, put this block on channel 2, and then it only affects that block. Find my directional light. Change this down to like 1. Okay. Cool. Good base to start with. From here, we have to build up our actual shader that we're going to use for our object. So So in Unreal, this works a little bit differently. I'm not going to show you the entire process because that'll be more when we get to environment art stuff, but let's just build a shader here. I'm going to go to materials. We've got a bunch of existing ones, but I'm going to hit new material and we'll just hop on into it. So just like Blender's BSDF or whatever it's called, we now have a material shader, and this is an Unreal lit material shader. Okay, and we can adjust all of these different settings. So we have a lot more to work with here. Let's, just to get started off, pop in our textures. So open the content browser, and I'm going to import all of our textures. So just find a textures folder. There's a bunch already. No, we don't want any of them. So we'll import some new ones. Import desktop, meet mat, Unreal, and we'll drag all these in. Bing, 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 bing. But we're not done yet. There are two more things we need to do. So by default, it's going to import our normal maps. Because they have the word normal in them, it will automatically convert them to normal maps. So in Blender, remember, we had to set like non-colored. Here we have to do the same thing, but on another level. So these, by default, if I hover over it now, because we've imported it, it's going to show up as normal map. So if we look at our formatting, it says up there BC5. Okay, it's going to import as a normal map by default. So these ones are okay. We click, we open, normal map, BC5. However, our masks, there's no default thing that opts to make this a mask. So it's still going to try and blend between all the red, green, and blue channels. And so if we blend between these different masks, we're not going to get the result we want. So over here in compression settings, we have to change this from our default to masks, which will disable sRGB and start to read these as linear channels 0 to 1 in red, green, blue, and alpha. So set this to masks. Boom. We can check. There's our roughness. There's our AO. There's our metallic. Okay. Go ahead and save that. And now we've got to do that for all of the different masks. So I'm going to just click this one and open it, and click this one and open it, and just do the same thing. So quickly, masks, no sRGB, save. Come over here, masks, no sRGB, save. Okay, now that we have all of our textures in, we can quickly grab them. So let's do the head for now. Head, base color, drop it in. Normal texture, drop it in. Mask, drop it in. That is it. That's all we need, right? A lot cleaner. So we can take our base color, which is a color map, and we can just drop that straight into base color. And you can see by default, the texture sampler is breaking up our textures into all the different channels. So our normal map, obviously we need all of the different channels. So I'm just going to drag this and drop it straight in here. Unlike in Blender, we don't need a normal map conversion node here. We can just drag our normal directly in, and you can see it showing up. Remember, this is a DirectX normal because we exported using the Unreal template. If you're creating your own template, make sure to set it to DirectX for Unreal. With our masks over here, we're going to take the red and drag that into ambient occlusion. We're going to take the green and drag it into roughness. And we're going to take the blue and drag it into metallic. Okay. And we've created one of our materials, right? Because of the way this is set up, we have to create a bunch more. But it's easier here. The material I just created is called a master material. So master materials allow you to create instances of them. If I go back to my materials now, I've made this new material. We can just rename it Matt. Okay, and I can drag it onto his head. And now I've got the concrete, and our lighting is too bright, but generally speaking, it's now on his head. So let's get rid of the skylight again, and the directional light. Okay. Great. For the body and the other parts, though, in Blender, we had to kind of recreate everything, which is annoying. In Unreal, this master material, which I can prefix with MM, okay, you'll see all these different things here that start with M. If I right click, I can press create material instance. And now I don't have to completely recreate the material. I just need to make it so that I can change the images, and everything else is easy after that. And I can actually just reuse this for anything. It doesn't have to be just matte. I can reuse this everywhere. So let's go back to our master material. These texture samples by default are not visible in our instances. So you can see I have nowhere here to change them. But if I right click them and convert to parameter, let's call this base color. Gonna right click this one, convert to parameter, normal map. Right click this one, convert to parameter, and this is a AO for ambient occlusion, R for roughness, and M for metallic. So ARM map. Okay. Oh, we're back. I thought the recording was going to crash too. Okay, we're kind of not back. Yeah, I'm afraid if I click OK, everything is just going to break. So I'm going to quickly check this. I'm just stopping and starting. It's very bold, which is why I'm stopping and starting it. Okay, hit OK. Yeah, there you go. Okay, but it didn't break. Didn't break Unreal. Or sorry, didn't break the recording. Anyway, once you have the master material and you created those parameters, you can just click on your material instance and it will open up a menu that lets you change the textures. So we could have really quickly gone in and changed those textures out for any other textures. Even if it wasn't the meat matte materials, it still would have worked. We could have had a ground texture or a texture for a wagon or anything else. As long as we have the textures for it, we can swap it into that material instance and reuse that somewhere else. Actually, that opened pretty quick, but everything is gone. So we'll call it there. Hopefully you caught that last part. If you didn't, it'll be in the recording. I'm going to stitch these two little bits together when I upload it. That is basically it, though. Is there any questions for that kind of stuff? I would really recommend rendering in Unreal if you're not going to use Marmoset. I didn't show you Marmoset, obviously. I don't have it installed on this computer, and I think you only get one license, and it's on my desktop. If you can find access to Marmoset, feel free to shoot me a DM. I will help you through the process of doing basically what we just did, but for Marmoset instead. It's a great render. It's fantastic. I can show you how to get the thing set up. Because I won't see you again before the submission is due, just remember it's going to be next week. Okay? If you are struggling and you're falling behind or feeling behind, reach out to Superior Iray. Happy to help. I might be working other things, but I'll get back to you as soon as possible. Superior, again, stays up till like 4 a.m., so he's your late night guy, and I'm usually up at like 5:30, so I'm your early morning guy. If we look at the actual assignment page, is this? Yep. Not that one, this one. If we look at the actual assignment page, remember you're going to be submitting in a portfolio style example. So it's in the submission example here. If I just click this, okay, this is the one that I did. Show off the different parts of your mesh like I just kind of highlighted. Add some things here and there. I don't know, this one just has baseballs flying around it. I like to watch baseball on these things. Make multiple renders and views, orthographics, show me your wireframe, show me what parts of your mesh are normal matte baked and what parts aren't. Show me your UV unwrap and how it's all laid out, right? Give me an idea of your different textures and materials that you've made throughout, right? And if you have Marmoset, add a Marmoset viewer. If you don't have Marmoset, upload it to Sketchfab. I don't need to teach you Sketchfab. You should all be well aware from last year. And when you make a new portfolio piece, you can actually right here embed Sketchfab. Okay, you just add your Sketchfab URL and it will show up in your post so I can quickly find it and review it on Sketchfab as well. Okay, so that is how everything should be submitted. Do keep that in mind. There will be marks for the submission itself. There's 12 points for quality and presentation. That includes the submission format itself. 5 for planning, process, and references, so include those as well, right? And then 8 points for technical execution. It should all be in one ArtStation or Behance or equivalent post. Okay? All right. that's it. Have a good rest of the day.